video, we'll solve first order differential equations in terms of the substitution method, alright, as promised. And therefore the question is, it's this one, right? And therefore what we can do is in terms of substitution. As you can see, we have in terms of some t and some x's, right? And therefore it's kind of like a little messy. So what I can do is just to sum them up together. I mean, just to bring this dude. Alright, I'll just bring it all the way down here. Meaning I'm just dividing everything by x squared. Alright. And alright. And therefore what we have, if we were to cancel out each other, so I have t cubed, tx squared plus x cubed, tx squared. Alright, you would have this t will cancel out with this, it will become t squared. I will have t over x squared plus, if I cancel all this, I have just x over t, which is dx dt. And therefore you have this one. Alright. Now you may wonder when do I need to know when is it substitution or when is it things like that. Alright, look at every term. Alright, just kind of take a look. Alright, if I just bring this thing, this is in terms of third order, right? Because it's in terms of cube. This term is also third order. And what about this? T times x squared is also some third order, right? Because it's one term times, in other words, t times x. There's three terms in there, right? Just like t cubed. T cubed is t times t times t. X cubed is x times x times x. Alright? And therefore this is the thing about substitution. You need to know that if they have the same order, alright, all the terms have the same order, this means that you can do in terms of substitution. Alright. And another thing is that you see this type of trend, t over x or x over t or whatsoever, then you will know that you should do some substitution. So can I do u is equals to x over t, or can I do u is equals to t over x? Which one is more preferable, right? If I were to do substitution, it really depends on situation. But I would still suggest that you do in terms of something that is without some order, like this is 2, right? I mean, this is like just there's no order at all, it's just 1, right? Instead of this, there is some 2 over here. If you were to do, it's not that good, I don't know. It seems like it. So I'll just take this, right, in terms of u. And along the way, you may also use, not along the way, but rather than you can also use in terms of u is equals to t over x. But later on, in the later parts, you start to feel that you shouldn't have done that. Alright, so it really depends on which terms you choose, but rather than that you choose something that is pretty straightforward like that, there's no order over here. So you can just take this one, u is equals to xt. And therefore what we can do is that dx dt is equals to u to negative 2, because u is equals to xt, alright? U minus 1 is equals to t over x, right? So because this is t over x, so we have u minus 1 times square, because this whole thing is square, right? I hope you get what I mean. And therefore plus u, alright? And it seems pretty neat, alright? And what we're gonna do next? So we can say that the first thing we need to do is to do substitution. The next thing we're gonna do is to differentiate. So what do we differentiate, and what is the thing that we're talking about in terms of differentiation? It's this one. We're gonna somewhat replace dx in terms of u. Alright? So how do we do it? Okay, we know that our u is equals to x over t. Correct? So if it's
Now because I want to write in terms of, I want to replace dx dt, right? I want to replace this term, so what can I do? So simply I will just bring this t upwards to the side. I multiply both sides by t. I would have tu is equals to x. Alright, and then I differentiate dx dt is equals to, alright, take this as a product rule. Please do not just differentiate weirdly. Alright, you would have, I think I'll just rewrite. Hold on. So what we can do is to differentiate in terms of t. So if I differentiate in terms of t, I'm just simply taking u, right? Imagine you have some 3t. If you differentiate t in terms of t, you'll get just 3, right? And that's just the term itself. So if you differentiate ut, you just get back u. Alright, and then you plus, right, because you're just differentiating this term. Alright, and then you plus, now you differentiate in terms of in terms of u, sorry. So if you differentiate in terms of u, what you have is du dt, right? And then you keep t, okay? And then you keep t. So in other words, if you still feel confusing, I'll just rewrite this as ut, okay? So for example, if I differentiate in terms of t, I differentiate in terms of t, which this is some coefficient. So if I differentiate in terms of t is equals to 1 if you differentiate, right? If dt, I think you get what I mean. If you differentiate t, what do you have? You have 1, alright? You have 1, and then you keep u constant, so times u, which is what we have over here, alright? And then if you were to differentiate in terms of t in u, because this time we differentiate this, we keep this. Now we differentiate this, we keep this, and therefore if you differentiate du, you have du over dt, and then you keep your t over here. This is exactly what I'm doing, okay? Hopefully this is very clear. And yeah, now just simply sub in dx dt is equals to this term. So I'll just sub it in over here, alright? And therefore I would have u, maybe I'll just rewrite. So I'm just simply rewriting dx dt is equals to this term we have just derived, alright? And therefore we know that at this side there is u, at this side there is u, we can just cancel. Or in other words, if I bring this over here, it becomes minus u, and they will cancel each other, it becomes 0. And therefore if I were to do that, I will left only this term. Alright, I repeat again, I have this u over here, I bring this over this side, it becomes minus u, right? So u minus u becomes 0. I cancel off each other. Okay, so things is starting to get a little more clear right now. And let me rewrite this as 1 over u square. Alright, and then I'll just rewrite this over here. Now we rearrange in terms of separable. Right, we can now solve in terms of separable equations if you still remember the Khan Academy one. If you don't remember, you just search for Khan Academy separable equations. Now you're going to separate in terms of du and dt, right? So u square, meaning I'll just bring this up to the side. I have u square du is equals to, this is dt, I'll just bring it up, it becomes dt, and then this t will go down, it becomes 1 over t. Right, I'm just simply rearranging only, alright, in terms of this form. Now, when you see du and dt behind all these terms, you know that straight away you require integration. Alright, and when you integrate, you would have 1/3 u cubed is equals to ln t plus ln c. Alright, where c is some arbitrary, you can say that you write c, but in terms of neater way, we recommend that you write ln c. Later on you'll know why. And therefore, actually, I'll just highly recommend you remember this form. If it's in terms of t, then you put it in terms of, if it's in terms of ln t, you put in terms of ln c. If it's in terms of et, you in terms of ec, something like that.
Alright, it should be fine, right? And therefore now we're gonna rearrange this ln TC. If you remember the logarithm rules, ln plus ln is multiplying each other, meaning ln A plus ln B is equals to ln AB. This is the meaning of it, right? And therefore we have ln TC. Okay, and then now I bring this 3 upward to the side, so I cancel out this thing. I have 3 ln TC, and then I square root this, so I have 3 ln TC, and then is equals to, now I replace u. Please remember to replace u back. I repeat again, please remember to replace u back. Alright, what is u? U is equals to xt, right? And x over t, u is equals to x over t. This is what we have just done earlier, right? Just replace it as x over t, right? I repeat again, please remember to substitute in. Okay, and then now I'm gonna bring this t out to the side, right? So I'm writing in terms of x is equals to all the t's on the other side, right? And that's it. This is the answer. So normally first order differential equations, you're gonna write answers in terms of, if let's say this is dx dt, then you're gonna write an answer in terms of x is equals to some t's, right? This is the meaning of it, right? So I hope that this actually helps you in understanding the concept of substitution. And in the next video, I'll just do up something that is combining all this. Alright, it'll be fun. So I shall see you there. Bye bye.